Um, thanks for the introduction. I really am just a molecular biologist, I think. And I think I'm becoming more of a molecular biologist as I get older, but so I'm not a philosopher. I think I'm what Thomas Perdue said yesterday at breakfast, that I'm a naive realist, which I think most of molecular biologists are. But I think maybe what I have to say is going to be of interest to some of you, particularly to John. So I'm hoping that, because I think it has the unintended consequence of Darwinizing Gaia. I mean, it's a process philosophy kind of thing. So my goal, however, is very modest. It's to legitimize the Gaia hypothesis in a way that Darwin and naive realists like me would approve, not to prove that the Gaia that Gaia actually exists. I think that's Jim Linton's job there. So that's an empirical question. I don't do empiricism anymore. And this is also an ad for my book, which is coming out in December from MIT Press. And I recommend that you all buy it. So Darwinizing Gaia, which is the same as my talk was called. Am I audible, by the way? Okay. So here's my outline for this talk. I'm going to remind people what the Gaia hypothesis is and why Darwinists considered it illegitimate, basically. I think the reaction of Darwinists to the Gaia hypothesis was instinctive and negative. Then I'm going to suggest, because Elliot Sober suggested it to me, and Thomas Perdue gave an award or prize to Elliot Sober recently, and well, anyway, that's going to follow along with that suggestion. But I think it's going to be a failed attempt to encompass something like Lewontin's recipe, which is what I think most people think evolution by natural selection is. And then I'm going to talk about, so that's a failure. Then I'm going to talk about a possibly successful attempt to rescue the Gaia hypothesis using Lewontin's recipe, but for differential persistence, not differential reproduction, which is what I think it's normally cast out as. But it's also consistent with the gene's eye view, which is what I'm sort of favoring. And I think this all aligns with John Dupre's process ontology in a sort of a way. So that's my goal. And so the Gaia hypothesis, which is the product of Jim Lovelock, but also aided by Lynn Margulis, an evolutionary biologist, a crazy person from the US, was first published in 1979. It was the result of some earlier work by them. And Gaia was claimed to be the largest living creature on Earth, and they said that the notion of the biosphere is an active adaptive control system able to maintain the Earth's in homeostasis. We are calling the Gaia hypothesis. So that really is the Gaia hypothesis, I think. I'll try to read only the red comments because people have pointed out to me that I read too much slides, and I can't really stop that. So I reacted very negatively to the Gaia hypothesis, and I published this thing in the Co-Evolution Quarterly with comments by Lovelock and Margulis, and I said that it implied, the Gaia hypothesis implied a high level of interspecific altruism, but I didn't think that was possible. Natural selection could favor that natural selection could favor the development of one species of behavior pattern, which is beneficial to another, unless it also benefited the first species. I'd secondly would argue that it was cheater prone, that the hypothesis, the Gaia hypothesis, was extremely vulnerable to cheaters, irresponsible mutants, and furthermore, I didn't doubt that Gaia existed. It's possible that it exists, but it couldn't be natural selection that produced Gaia. So I doubted that it was caused by natural selection, and I think that's what most Darwin said, and Dawkins, Richard Dawkins, much more famous than me, said about the same thing, but a year later, the universe would have to be full of dead planets whose homeostatic regulation systems had failed, with dotted around a handful of successful, well-regulated planets, of which the Earth is one. In addition, we would have to postulate some kind of reproduction whereby successful planets spawn copies of their life forms on new planets. So basically, Dawkins was saying that there are two things wrong with the Gaia hypothesis. One is that there's no population of Gaias, but there's only one Gaia, and therefore it's not interesting, not an interesting evolutionary proposal. And secondly, Gaia doesn't reproduce, so there's no reproduction. I mean, the obvious species within it, the individuals within it, reproduce obviously, but Gaia itself doesn't collectively reproduce as a thing. And Lewontin's recipe requires reproduction of things as things. The Dawkins' own version of the genes IV might in fact allow Gaia as a collection of extended phenotypes, which is what I'm going to argue later. So, and I think we Darwinians, which I would call myself one of, and Peter Godfrey Smith, who isn't here, and possibly not popular with this audience, but he's, I think, the spokesperson for natural selection at the moment with his 2009 book, Darwinian Populations. He said, but these benefits to life are byproducts, they're accidental. The interactions between species are consequences of the traits and behaviors that evolutionary processes within those species give rise to, and these processes are driven by reproductive competition within each species. So basically, it's an accident whether or not Gaia exists. And I think he's doubling down here on Lewontin's recipe, which is what I think most molecular biologists like me think that natural selection is. So he says, evolution by natural selection is a change in a population owing to variation, heredity, and differential reproductive success, which is basically heritable variation in fitness, or basically Lewontin's recipe. He then endorses multi-level selection, which I do too. The criteria required are abstract. Genes, cells, social groups, and species can all, in principle, enter into change of this kind. That's fine. And he says also that for any objects to be units of selection in this sense, however, they must be connected by parent-offspring relations. They must have the capacity to reproduce. And I think that the Lewontin's recipe formulation is very much dependent upon differential reproduction. It is a formulation dependent on differential reproduction, and multi-species communities don't reproduce. Gaia doesn't in particular reproduce as a unit. So that's the problem. So Thomas Perdue, who's I think the next speaker after Coffee in this symposium, gave an award recently to Elliot Sober, who was, another respected philosopher of biology, probably the most respected in some ways, the earliest one, suggested to me that in a comment to a paper that I had written, but don't communities in fact reproduce just like sexual organisms, only with more parents? And he's of course right. And so what Eliot meant by that was that sexual organisms only have one cell, a cell that reproduces them. So they only have one parent, basically. Sexual organisms have two parents, basically, the gamete donor and the sperm donor and the egg donor, which is what Paul was talking about previously. Many algae and fungi go through a haploid stage. I mean, they might be haploid much of the time, and so they're really good gametes, and they undergo natural selection as gametes. So that happens. And so why can't we just regard multi-species communities as, having many parents? There are many parents, all individuals of however many species that make up the ecosystem. And I would say just that that's often too many. And again, I would refer to Peter Godfrey Smith. Well, yes, they do. The multi-species communities do reproduce in that sense, but in the same sense that that sexual organisms do. But I would say with Peter Godfrey Smith that there are too many parents. So the way he presents the Darwinian paradigm in the 2009 book is simplicity itself. It's possible to have evolution by natural selection on units where reproduction is sexual and heredity is weak. I think that's perfectly permissible as a classical statement of what natural selection is, but there are limits then, and Peter Godfrey Smith recognizes those, and I do too, but there must be some parent-offspring similarity, and the clarity of a parent-offspring relation of the relevant kind is inversely related to the number of parents. If there are too many parents, there are no parents at all, which is the problem, I think. So how that casts out in the terms of multi-species communities is different from how it cashes out in terms of sexual organisms. So that's a three-part argument that you have to make now. So I just will read them. One, the too many parent problem needs to be interpreted one trait at a time, even within species. So there's no mixing of wrinkly and green, referring to minerals. Peas. Lewontin's recipe works because offspring resemble one or the other parent, or their average two parents, in all traits because there are only two parents, and these are basically always the same two. And I think Paul pointed out that there are only two parents involved, even though there are multiple ways to make it two parents. But for multi-species communities, there can easily be too many parents. Each trait can have different parents, for instance. So there are too many parents. So for example, the species responsible for photosynthesis is not often the nitrogen-fixing species in an ecosystem. So ecosystems are different from organisms in the sense that they have too many parents, that's all. So for multi-species communities, the parent-offspring resemblance required by Lewontin's recipe increasingly fails. So Lewontin's recipe fails because there is no longer any particular parent that an offspring resembles. There are too many reproductive lineages. There's too many parents. So that's a failure. What's possibly successful is, well, one of the things that I proposed several years ago now, but probably nobody's read it. And so I'm going to argue again for differential persistence as being part of Lewontin's recipe, or possibly also consistent with the genes IV, which is what I'm sort of preferring at the moment. And then I'm going to try to align this with two-phase process philosophy. So the paper that I published relatively recently with Celso Neto after a long debate with philosophy of science, it's sort of this, and so it's based on a chemostat model for clade selection. So those of you who don't know what a chemostat is, it's just a device, a molecular biologist's favorite device, and it's one of their favorite devices, where fresh medium without cells comes in, and an equal volume of medium plus cells is pissed out and from the chemostat, and you can monitor such a chemostat so that it maintains a constant cell density, for instance. And it's the consequence of coalescent theory, for one thing, that at some future time, all cells in the chemostat will descend from a single cell present in the chemostat at some previous time, right? I mean, that's an obvious conclusion of that. And of course, natural selection, if it favors a particular cell lineage, will increase that rate at which it fixes. So that's our model for clade selection as well. So we're assuming that clades are equivalent to clones, or at least analogous to clones, because they both have the same definition, an ancestor and all its descendants, living or dead. extinct perhaps. So this is in terms of clades. I mean, those are species, S1 and S2, and of course, there is one clade starting with 0 or O, but you could define a subclade starting with S or a subclade starting with S1, 2, or it's all clades and subclades. And so clades can't reproduce because any product of the clade will be part of the clade. In that sense. So how does that relate to Gaia? Well, I would say that Carl Woese has shown that, and I think common sense would show, and Darwin argued that all living things on Earth today are descended from some last universal common ancestor, Luca. And Carl Woese has shown that bacteria, eukarya, and archaea, the 3 domains that now define all of living things. But Luca was also a fairly sophisticated cell that had many advanced features in it. So it probably, I mean, almost certainly didn't exist alone in its population. But there were competitors of Luca, starting population, which was highly competitive, but most of those have gone extinct, possibly transferring some genes into Luca or its descendants. But so I think that's got to be true. So clades, I'll just read this. Clades, like all life, the biotic part of Gaia, cannot reproduce. By definition, they can't reproduce. They can only persist or go extinct. But clades, like clones, continuously generate their own lower level populations. In the case of clades, the species that compete to found the future clade. So are there selectable properties that particularly adhere to clades? I mean, that can be attributed to clades, and I think there are. So that's point number 3. And clades are selected for size, which is perhaps trivial, but also for ecological diversity. It could be that within species, it's not actually advantageous to have the gene that makes you variable. But between species, it could be, because the clade might survive as a clade because the species are genetically variable, or environmentally variable. So ecological diversity is a selected for trait of clades, and geographic dispersal is obviously selected for trait of clades, and possibly mutual aid. I mean, like most organisms on Earth can eat other organisms, or omnivores can eat, or carnivores can eat other organisms, and that's because they're made up of the same amino acids and stuff. So it's edibility is one of those things, but like a lot of transfer is probably not. So how are we doing for time here?
You got 2 minutes. 20 minutes of the whole thing, but 2 minutes of talk.
Oh, okay. Well, so there are reasons why Luca was selected, and the particular Luca was selected, and I'll just read this paper by 2 Serbs. This biosphere, be it alone or one of many, is accordingly a product of natural selection, since the overall evolvability conferred by its coding concept, their term, nucleic acids as information carriers with a rule book of meanings provided by codons, as well as all the subsystems that regulate various conditional information reading modes, certainly played a key role in establishing this biosphere to survive up to the present, though through alterations of planetary conditions, including at least 5 events linked to major mass extinctions. So I think this is an example of downward causation. True. So you can cash this out in terms of Lewontin's recipe. You could modify Lewontin's recipe to include differential persistence. So that's indicated in green there. Clades in the past would resemble clades in the future. That would be the mechanism of heredity for clades. Somewhat dubious. And different variants will last variously long. That's quite clear that they would, on the basis of those principles that I articulated. So either we can use Lewontin's recipe as modified in green, or see clones clades as interactors interacting with their environment, as in number 3 on the previous slide, and regenerating lower level populations as in number 4 in the next. So here's what I'm going to say next. Number 4. So if we're willing to use Lewontin's recipe and make this process interesting, which Akash has said that it wasn't interesting, we have to allow that selection can occur at a higher level than reproduction, which establishes the population. So that's the claim that I'm making, is that we can allow the population to be established by a lower level process, whereas selection happens at a higher level, which is basically what the gene's eye view does. So this is what Dawkins and Hall's version of the gene's eye view already does. David Hall would say that selection is a process in which the differential extinction and proliferation of interactors causes the differential perpetuation of the replicators that produce them. So the clade within this be simply an interactor. So then I can argue about the hierarchy of life. So the things that are pink, the ellipses that are pink, are all reproductive entities and would fit into Lewontin's recipe, as Peter Godfrey Smith understands it. There are both replicators and reproducers, or reproducers and interactors. They're simultaneously both of those things. And Lewontin's recipe does apply to those things. But Lewontin's recipe, being as it is hitched to differential reproduction, doesn't apply to interactors which don't reproduce, namely multi-species communities or Gaia. So these are non-reproducers, but they are interactors after all. They do have selectable properties. So Lewontin's recipe does not apply, but an extended gene's eye view does. Especially if we extend the gene's eye view, which I think we can legitimately do, to allow non-reproducing interactors and species as replicators. So that's what it's the song, not the singer theory, which Scott Gilbert referred to yesterday, does. Just to go through that theory, a multi-step process, interaction, or metabolic biochemical cycle or pathway exists. Each step offers opportunities to organisms to make a living performing it, so that guilds comprising many species thus evolve to take advantage of these opportunities. Lateral gene transfer facilitates this evolution. So I would say, because there's a song, there are singers. That's the process of recruitment. 4, when members of different guilds reassemble, they implement the whole process again, reproduce it though. Okay, well, each one knows only its own part. Because there are singers, there's a song. So persistence of the process continues through its reproduction. It's being produced again, not reproducing. Reproduction. So I think this microbiologists have been thinking this way for some time now. This quote from a paper by Paul Falkowski et al. In essence, microbes can be viewed as vessels that ferry metabolic machines through strong environmental perturbations into vast stretches of a relatively mundane geological landscape. The individual taxonomic use and evolve and go extinct, yet the core machines survive relatively surprisingly unperturbed, I think. So there's a problem with thinking this way, which has been pointed out to me by many philosophers, which is that I'm implying that an immaterial thing, a process, can cause a material thing, taxa, to evolve, and that seems to be a no-no. And there are 2 ways around that. So, and I think aligning with John Dupre's process ontology is one way to go. So I think there are 2 ways to go. One could view the things as all things, which is what I think Tyler Wolff does. I'm not going to read that quote. Or you could view it as all processes, which is what John Dupre does, and I think that's probably the way to go, because it's not really. I mean, the songs really are processes. Or you can regard it as Baptiste and Papal, who has a combination of those things. So perhaps we're already there. Because I think Nicholson and Dupre's book, very strongly states this, that the interconnectedness of life challenges all these substantialist assumptions. Organisms persist by virtue of the intricate webs of the relations they maintain with one another, which in part endow them with their distinctive properties, capacities, and behavior. I think that's Gaia hypothesis, basically. So anyway, I'm done. These are people that have contributed one way or another to my scientists already show these slides. Those are, but there are a lot of philosophers and relatively few biologists here, but Tim Linton is one of them, and modelers. Basically, that's what the N stands for. So thank you.